All right, let's talk about something every single person who's ever written code has said, probably through gritted teeth. But it works on my machine. It's the most frustrating phrase in tech. Today, we're going to unpack the tool that was built to make sure you never have to say that again. We're talking about Docker.
So, what's the deal with that anyway? Why does this keep happening? You spend weeks, maybe months, building something amazing. It runs like a dream on your computer. You hand it over to a colleague or you deploy it to a server, and suddenly, it completely falls apart. What is going on?
To really get this, let's paint a picture. It's a classic story, a tale of two machines. Imagine a data scientist who's just built this brilliant machine learning app. It's designed to predict the price of laptops, and on their computer, it is absolutely flawless.
So check this out. Our data scientist finishes the laptop price predictor. It's working perfectly. They push the code up, share the link with a tester, and feel pretty good about it. The tester downloads it, fires up the application, puts in some laptop specs, clicks predict, and bam, crash. A big, ugly error message.
And this is what the tester sees, just this wall of cryptic text. Now, you might look at that and think, oh, there must be a huge bug in the code. But the real problem? It's something way more subtle. It turns out the data scientist was using version 1.1 of the scikit-learn library, but the tester had version 1.0 installed. That tiny little difference in their environments was enough to bring the entire application to its knees. So how do we get out of this mess? How do we fix this environmental chaos? Well, the solution is actually incredibly intuitive. And to get our heads around it, we're going to talk about, of all things, instant noodles.
Okay, stick with me here. Imagine if your instant noodles didn't come with that little sealed spice packet. Instead, they came with a recipe book. You'd have to go find all your own ingredients to make the spice mix. Now, even with the same recipe, my chili powder might be spicier than yours, my salt might be different. The noodles would taste a little different every single time. But with that sealed, pre-made spice packet, you get the exact same perfect flavor every single time.
And that right there is the big idea. Giving someone just your code is like handing them the recipe book. The results are going to be inconsistent. But packaging your code with its entire environment, all the right libraries, all the right versions, that's the spice packet. That's why we say Docker is the spice packet for your software. It guarantees the same result every time, no matter whose machine it's on.
Okay, so we get the why now, right? Docker is the magic spice packet that ensures consistency. But what's actually in that packet? Let's break down the core components that make all this magic happen.
First up, you've got the Docker image. This is the blueprint. This is the sealed spice packet itself. It's a single self-contained file that has everything your application needs to run. Your code, the right libraries, the exact versions, all the settings, the whole shebang. It's a perfect frozen-in-time snapshot of a working environment. Next, there's the Docker container. Now, if the image is the spice packet, the container is what you get when you actually cook it. It's the perfectly prepared, steaming hot bowl of noodles. A container is a live, running instance of your image. It's where your application actually lives, breathes, and does its thing. So you might be wondering, how do we even make one of these images? Well, that's where the Docker file comes in. It's just a simple text file, and it acts as the recipe for your spice packet. It's a list of step-by-step instructions that tells Docker exactly how to build that perfect, self-contained environment for your code. All right, so we've got our three core pieces. The recipe, which is the Docker file, the sealed spice packet, which is the image, and the final dish, the container. Now let's see how these all come together in a really simple and elegant workflow that makes this all possible. Now, once you've created this perfect spice packet, this image, you need a place to put it, right? A place to store and share it. That's where a Docker registry comes into play. Think of it as a central warehouse for your images. It's kind of like GitHub, but instead of just storing your code, it stores the entire ready-to-run environment. The most popular public one is called Docker Hub. And all of this comes together in a super straightforward 4-step process. First, the developer uses that Docker file to build a portable image. Second, they push that finished image up to a registry like Docker Hub. Third, anyone else, a tester, a server, a colleague, can pull that exact same image down. And finally, they run it, and it springs to life as a perfectly working container. And just like that, the "it works on my machine" problem is gone. You know, this is more than just a neat little trick for developers. This fundamentally changes the game when it comes to building and shipping software. So let's talk about the real payoff here. Why this should matter to you. For starters, consistency. That "it works on my machine" nightmare? gone for good. Then you get isolation. You can run an ancient app that needs Python 2 right next to a brand new one that needs Python 3 on the very same machine, and they won't even know the other exists. It makes scalability a breeze. Your website's getting a ton of traffic? No problem. Just launch a few more identical containers. And finally, you get true portability. If it runs in a container on your laptop, you can be confident it's going to run the exact same way in the cloud.
So at the end of the day, Docker takes your code and everything it needs to survive, bundles it all up into this neat, tidy, standardized box that just works anywhere. It frees you up from all those frustrating environment headaches so you can focus on the thing that really matters, building amazing things. So the only question left is, now that your code can run anywhere, what are you going to build next?